I'm here in the East Building at Zeiss Industrial Metrology talking to Chris Daly about their newest product. How are you?
I'm good, Whitney. Thanks for having me.
Absolutely. So tell me about the machine we're standing in front of.
The machine we're standing in front of currently is one of our coordinate metrology offerings. This is called an Acura coordinate measuring machine. The product offering on the Acura is our new surface finish sensor that we call the Rotos. This product enables the user to take highly accurate surface finish and or waviness measurements while the part is being inspected on the coordinate measuring machine as part of our Calypso measurement plan. This device actually resides in the rack and can become part of a standard probe change pulled out of the rack so that the measurements can take place. We have full rotation and full indexing capability on this measuring head. It's also important to point out that this is a full skid-less measurement. It's not a skidded device.
So what are some of the benefits of this?
The benefits of this primarily are not requiring additional time to take the part after it's been inspected on the CMM and take it to a quality lab for surface finish measurements by a dedicated device. Further to that, all of the data is transferred via Bluetooth to the computer and is part of the Calypso inspection report.
So what sorts of parts would be measured on this machine?
The part that we have on the machine currently is an excellent example. Characteristically, you'd want parts that were complex, that is to say they had a lot of features, and there's a surface finish requirement on several, if not all of the features, and every single part requires a surface finish measurement.
All right, we have a few other different kinds of machines here. Let's go take a look at those.
Okay, let's do it. What we're looking at here, Whitney, is a couple of new versions of some product that has been on the market for a while. This is our laser line scan device on the new version of our Contura series of coordinate measuring machines. Like the Acura, the Contura is made in our factory in Maple Grove, Minnesota. This laser line scan device is offered in 3 different styles and is fully supported in an automatic probe change, so you could use the laser line scanner as part of a program that also involved tactile metrology. As you can see here, what we're using it for is to take multiple scans on this larger workpiece so as to provide a very large data set to compare to a CAD model and also look at surface profiling.
What are some common applications of this scanner?
Oh, great question. Thanks, Whitney. One of the common applications for this sensor is to use the laser scanner to paint the part several times, generate what we call a point cloud, and then that data set is used to actually model the part, or what's commonly called reverse engineering.
Okay, well, let's go see one more thing.
Okay.
Chris, tell me about this machine.
Whitney, what we're showing here is our OInspect product, and this is offered a couple of different configurations. And what we're doing with the OInspect is we're actually integrating our tactile scanning 3D coordinate metrology expertise with an optical sensor to view, or inspect, I should say, those features that are too small or don't lend themselves to tactile scanning. Additionally, on this machine, what we're doing specifically is some measurements with our white light sensor, and that is a device that is used for taking very accurate measurements in the Z-axis when you cannot touch the part. Okay, this machine's offered a couple of different ways. We build the smaller unit in our Maple Grove factory, and it is also available with tactile and vision as well.
So what sorts of industries would use this product?
Small machined components, companies that make small machined components. Plastic injection molders are a big consumer of this product as well, and some of the rubber or connector type products, again, products that don't lend themselves as well to being touched because they're too soft or can be too easily damaged.
Like medical.
Exactly. You read my mind. Like the medical industry, in some cases you simply can't touch the component. Once the manufacturing process is over, because that component may be going into a patient's body.
So what is this particular part that you're inspecting now?
That component actually is what's called a guide bar for a chainsaw. We all know what a chainsaw looks like. If you imagine the part that the chain actually turns around on, there's some very tight measuring requirements, precise tolerances, I should say, on this component, and it lends itself to mostly tactile inspection, but there are some features on that part that are too small to be probed, and so we use the vision component for that. And as you saw a moment ago, we were using the white light to scan some of the flatness measurements.
I see. Well, thank you so much, Chris. And there's a lot going on here in your booth. So be sure to stop by the Zeiss Industrial Metrology booth here in the East Building.